Hello students, today we are going to discuss about Hilbert Transform from Unit 1. The course outcome of Unit 1 is distinguish various amplitude modulation communication systems. Hilbert Transform. So what is Hilbert Transform? Normally transform is used for converting one domain signals into another domain, whereas in Hilbert Transform it is not actually a domain change. Here whatever you are giving, that is a signal x of t, there is no time domain change. Say for example, if you are going for a Fourier transform, x of t is transformed, then outcome will be x of f. Whereas here, if the input signal is x of t, the Hilbert transform of x of t will be equivalent to x bar of t in same domain with respect to time period. So the Hilbert transform of a signal x of t is a signal x cap of t whose frequency components lag the frequency components of input signal x of t by 90-degree phase shift. That is, x bar of t is exactly the same frequency component present in input signal x of t with the same amplitude, except there is a 90-degree phase shift delay. So we can write the Hilbert transform x of t. Input signal is a cos 2 pi f naught of t plus theta is equivalent to a cos 2 pi f naught of t plus theta minus 90 degree. That is, we are introducing 90-degree phase shift in the input signal. So a cos 2 pi f naught of t plus theta minus degree is equivalent to a sin 2 pi f naught of t plus theta. So a delay of pi by 2, that is 90 degree at all frequencies, is achieved with the help of Hilbert transform. So let us assume the phase component e power j 2 pi f naught of t will become e power minus j e power j 2 pi f naught of t. Similarly, e power minus j 2 pi f naught of t will be equivalent to j into e power j 2 pi f naught of t. So at positive frequencies, the spectrum of the signal is multiplied by minus j. Similarly, for negative frequencies, it is multiplied by plus j. You can differentiate here. Here it is a positive frequency, so the signal is multiplied by minus j. Similarly, this is a negative signal. Here it is multiplied with plus j. So this equivalent to saying that the spectrum Fourier transform of the signal is multiplied by minus j signum of f. So obviously, preparing the Hilbert transform on a signal is equivalent to 90-degree phase shift in all its frequency components. Therefore, only the change that the Hilbert transform performs on the signal is changing its phase component. So the amplitude of the frequency component of the signal does not change by performing the Hilbert transform. On the other hand, while we are performing the Hilbert transform, changes cosines into sines. The Hilbert transform of x cap of t of a signal x of t is orthogonal to x of t. So what is orthogonal? Orthogonal means 90-degree phase shift, or we can say perpendicular with each other. So also the Hilbert transform introduces a 90-degree phase shift, carrying it out twice causes a 180-degree phase shift, which can cause a sign reversal of the original signal. So here some examples are given, and corresponding properties are listed out here. Hilbert transform of a signal x of t is defined as the transform in which phase angle of all components of the signal is shifted by either plus or minus 90 degree. So this is a formula or a representation of x of t in time domain. So x bar of t is equal to 1 by pi minus infinity to plus infinity x of k divided by t minus k into dk. So this is x cap of t, or we can say Hilbert transform of input signal. So if we want to obtain the inverse Hilbert transform, the formula is equivalent to x bar of t is equal to 1 by pi minus infinity to plus infinity x of k by t minus k into dk. So we can call these two as Hilbert transform pair. Properties of Hilbert transform. Signal x of t and its Hilbert transform x bar of t have same amplitude spectrum as we discussed earlier. The same autocorrelation function relation spectral density is energy spectral density is same for both x of t and x bar of t. X of t and x bar of t are orthogonal with each other. X bar of t Hilbert transform is equivalent to minus of x of t. In Fourier transform exists, then Hilbert transform also exists for energy and power signal, which means if you are obtaining the Fourier transform for any input signal, that signal have energy and power. Similarly, it is applicable for Hilbert transform also. So these are all the examples of the properties of Hilbert transform. This is linearity property. H of ax of t is equal to ax of t, so we can expand with respect to the linearity property. Then double application, as I told earlier, if we are applying it, we can get 180-degree phase shift, or minus x of t can be achieved. Then inverse ht is equal to h inverse equal to minus of h, differentiation and convolution. Then analytic function xa of t is equal to s of t plus j into h of x of t. So these are all the important points you have to remember when you think about Hilbert transform. This is the signum function, and we can represent in the time domain Hilbert transform x g of f is equal to h of x of t, that is equivalent to 1 by pi minus infinity plus infinity x of alpha divided by t minus alpha into d alpha. So here this is the in phase component, and this is quadrature component. This is the transfer function of Hilbert transform h of x of t. Frequency in this axis, here we have taken the magnitude. Here it is represents the phase component of the same. So the magnitude is equivalent to 1. There is no change in this. Whereas if you consider the phase of the input signal, if it is pi by 2, then this will be equivalent to, if you are obtaining the Hilbert transform, this will be equivalent to minus pi by 2. That is, the transfer function of the same input signal is equivalent to e power minus j pi by 2 when f is greater than 0, and this is equivalent to e power j pi by 2 when f is greater than 0. And these are all the formulas you have to remember for Hilbert transform. If you are obtaining the Hilbert transform for sin t, it is equivalent to minus cos t, sin t. 1 by t square plus 1 will be equivalent to t divided by t square plus 1. Sin of t by t is equivalent to 1 minus cos t by t. Delta of t is equivalent to 1 by pi by t. So these are all the important formulas you have to remember for Hilbert transform. Thank you.